So hello and welcome to software architecture course. In this lecture we will talk about quality attributes, quality classes, attribute scenarios. We'll basically give an introduction to what is quality, which will be the basis for the next subsequent set of lectures. So let's understand what the quality classes are. To understand quality attributes, which is one of the very important aspect of software architecture, let's step back. So step back because let's understand what is functionality. When we say functionality of a system, essentially what we mean by that is it's an ability of the system to fulfill its responsibilities. So when a system is actually conceived, or when a system is in operation, in both the cases, system has a set of responsibilities or set of features. They are kind of synonymous. So essentially the system fulfills certain responsibility, it does some task. So that's basically its functionality. But quality attributes are something different and quite orthogonal to its functionality. It has got nothing to do with functionality. So if we are talking about, let us say, a television set, then its functionality is to essentially display pictures, images, videos coming from different sources. That's a functionality. But the quality attributes might be something very different. It might be the quality of resolution, quality of picture, ease of use, how good it is to integrate with other components, how good is the sound quality, etc. If you look at a sound recording system or a music player, then its basic functionality is to basically play some audio. But its quality attributes are again how good is the sound quality, how good is the music quality, how easy it is to use. Similarly for software also, there is a clear difference between the functionality and the quality attributes. Oftentimes people misunderstand and mix functionality with quality attributes. Sometimes, let us say, if a particular module or a particular piece of software is supposed to collect data at, say, at a very high speed, say 5,000 records it needs to process in a second, then the functionality is processing the records. Functionality is not about how many it can process. The functionality is about processing a record. And non-functional attribute is that it must be able to complete 5,000 record at least per second. So in a sense, software quality attribute becomes a constraint that the system must satisfy while delivering its functionality. Then the third element is the design decisions. It's basically a constraint driven by external factors. For example, in an organization, there could be a design decision that's already taken, that a programming language of choice should be something, or the platform should be something, or the infrastructure should be from a particular vendor, or network topology should be like this, or every single reusable component should be service oriented. So these are all the design decisions that are already taken. You cannot compromise, you cannot even question those. Those are all something that you must adhere to and then implement the architecture. So when you are building a software, we need to think of three things: the functionality, software quality, and design decisions. So software architecture comes after requirement. Therefore, at this requirement stage, you need to capture the functional requirement, you need to capture the software quality requirements, and we need to capture the design decisions. These three requirements will be considered to basically create architecture and then the design. In this course, we are not going to talk about functional requirement and functional requirement capturing, but in this particular lecture, we will basically understand software quality attributes in details, and we will understand how the software quality requirement can be captured, and then how those requirements can be addressed. So for example, if there are a requirement like this, that user interface should be easy to use. Now this is quite a vague requirement, and essentially it's not very clear. Is someone talking about radio button or checkbox or clear text or screen layout? It's really not an architectural decision actually. User interface should allow redo, undo at any level of depth. This is a good architectural requirement, and it's a usability requirement. It's definitely a software quality requirement, and architectural decision need to be taken here. The system should be modifiable with least impact. You can actually interpret that in two different ways. One is in order to make it modifiable, you could think about modular design. That becomes architectural decision, and that impacts the architecture. But coding technique must be simple. That's also a way by which the modifiability can be impacted. In fact, if the coding is simple, then one can change it easily, and then the impact is less. But this is not architectural decision at all. Need to process 300 requests per second. So interaction among components, data sharing issues becomes architectural concern. But in order to process 300 requests per second, you need to possibly choose a different algorithm to handle transaction. This is not an architectural decision. So for these four quality requirements, what we have illustrated is what is architectural, what is not architectural. So let's look at quality attributes and its functionality, and the functionality in slightly more detailed. Now, any product, and software product included, is actually sold based on its functionality. Which are its features? Very important. You don't buy MS Office software because it is very easy to use. You buy MS Office software because it offers certain functionality. Similarly, you don't buy a mobile phone because it looks good. You buy it because you want to make a phone call, or maybe you want to use it for sending SMS and so on. So providing the desired functionality is often quite challenging because of various factors like time to market, cost and budget, and rollout schedules. These are also different types of quality attributes. We'll look at it in shortly, though we are not going to cover it as a part of our course. But it's important to understand that providing this desired functionality is challenging. Now, functionality, please remember, functionality does not determine the architecture. It is a quality attribute that determines the architecture. Why? Because if functionality is the only thing that you need, then it is perfectly fine to just create a monolithic software blob in which you can actually implement all its features or all its responsibilities, and you are done with. So you won't require modules, threads, distributed systems, etc. So you just create a single monolithic blob, and that is fine. But it is because of the quality attributes there are many design there are architectural choices and decisions that come into picture. So functionality really does not determine the architecture. This is very important to know. What are the quality attributes? We know the attributes like availability, performance, security, usability, functionality, modifiability, portability, etc. Now these names I have taken from a standard called ISO 9126. Though the product is sold because of its functionality, but the success of the product will ultimately rest on its quality attributes. So you can sell a product, you can sell a mobile phone because you can make a phone call, but its success will finally depend on the quality attributes. For example, one can say it is too slow. That's a performance related problem. It keeps crashing. It becomes an availability problem. So many security holes in the system. It's a security problem. Reboot every time a feature is changed. That's a modifiability problem. Does not work with my home theater at all. It's an integration problem. So these are basically the quality attribute related issues that need to be addressed. So in fact, whatever quotes that I have used here are essentially complaints that the user is going to put when they are going to use the system. So either you take the complaint and fix it, or essentially keep that in mind and then address it at the beginning itself. So to address this needs to be really addressed throughout the design, implementation and deployment. You just can't do it at the level of architecture and then say I'm done with. Quality attributes must be done throughout architecture, design, implementation and deployment. And it should be designed in and also evaluated at the architectural level. At the architectural level, you must recognize what are the quality attributes that you need to consider and evaluate whether they're feasible or not. Quality attributes are non-orthogonal, meaning that they impact each other. One can have an effect either positive or negative on other. For example, performance is troubled by nearly every other quality attributes. If you want to achieve modifiability, you may have to sacrifice performance. So all other attributes actually demand more code, but performance actually demands the least amount of code so that it can run faster. So there is always going to be a trade-off, and that will be the role of the architect. Now let's see how we can define and how we can reason about different quality attributes. So the statement like system should be modifiable is quite vague and ambiguous. It needs to be clear, because unless it is clear, the architect cannot really design a system to address this, and it cannot even communicate this to the stakeholders. So it should be so clear that everybody should be able to understand it in an unambiguous manner. So system should be modifiable is really not a right requirement. If someone gives a requirement like this, as an architect, you should reject this requirement, and you should say that let's have more specific, more clear and unambiguous requirement. So second is that when a system fail, how do you associate that with a quality attribute? Is it when a system fail, is it because of availability, or is it because of performance, or is it because of security, or is it because of all of them? So in order to even understand that, we need to understand what is security, what is performance, what is availability. And unfortunately, everyone has his or her own vocabulary of quality. Therefore, it is important that we understand unambiguously what an availability means, what a performance means, what a security means. In this course, we will attempt to define these, and then essentially also attempt to give a template by which you can capture requirements and essentially reason about it. ISO 9126 and ISO, and later on ISO 25000, which is more recent, has attempted to create a framework to define quality attributes. You can look at ISO 25000. So what I was saying is that there are actually three quality classes. The first one is called the system quality. System quality is about the quality of the system that you're going to build, like modifiability, availability, performance, security, testability, and usability. In this course, we are going to consider these system qualities, and we are going to analyze that, understand that in detail. We will use a term called quality attribute scenarios to characterize each of them with a very attribute specific requirement, which is we are going to use these scenarios to actually capture requirement, and then we are going to use the same scenarios to basically reason about how those requirements can be met using architectural tactics. But there are other types of quality attributes also, like business quality and quality of architecture. Like the business quality is time to market, cost and benefit analysis, project lifetime, etc., schedules, etc. Now, some of them do have an impact. In fact, all of them have an impact on the software. In fact, if you just recall a few slides back, I was saying that in order to really deliver the functionality, you need to think about, things like time to market, cost and benefit, etc. plays a very important role. However, in software architecture course, we are not going to deal with these two qualities, like business quality and quality of architecture. So what is a quality attribute scenario? A quality attribute scenario looks like this. It's a pictorial description that I have put, but you can actually use your own template, or you can create a template to capture a quality attribute scenario. This is helpful to capture a requirement for a particular quality. So first one is the source or the stimulus who basically creates this particular scenario. So entity like human or other software that generates the stimulus. So who is actually using or generating this particular quality attribute scenario? Then when this stimulus arrives to the system, what is a condition that the system needs to consider when it arrives? So the condition could be the condition of the environment that the system needs to consider. So when the stimulus comes to the system, what happens to the system essentially, and what happens and where it happens? So the part of the system that is affected is essentially the where part and the when part. Some part of the whole system is affected so as a part of the requirement, it has to describe that how the system is going to be affected in order when this stimulus comes. Conditions when the stimulus actually occurs, meaning that what was the state of the system when this stimulus occurs. Response is that when this stimulus occurs and the system is affected by it, how does the system react, or what should the system do as a result of the stimulus? And measure is that how do you know that the activity or the response that the system has taken is actually good? So basically, it's basically a measurable response which can be tested for correctness of the quality attribute. So you can now use this template for all these attributes like availability, performance, security, and so on. Example is that you can say that there is an attack which is a stimulus, maybe a DOS attack created by a software. Now that DOS attack can happen when the system is in running condition. It can impact maybe module X, Y, and Z of the entire system. The response is that the X, Y, and Z should be able to counter this DDoS attack, and the measure could be that the response time of the overall system should not be impacted, or even if it is impacted, it should not fall below certain threshold. So this particular scenario that I have described just now for security can be treated as a requirement, and then as an architect you can capture the requirement in this format, and then you can use architectural tactics to address this particular scenario. So essentially, to achieve a quality, one needs to take a design decision, which is called a tactic. So the other design decisions that I have said at the beginning are the decisions that actually come from the organization, things like the technology of choice and things like that, on which you have no control. However, this particular thing is a tactic that is in your hand. This is the design decision that you are going to take. So a collection of such tactics is called an architectural strategy, and a pattern, whether it's an architectural pattern or a design pattern, essentially is a collection of such tactics. So when the stimulus comes and it is received by the system, tactics are implemented in the system to achieve the desired response. So in the requirement it is stated that what should be the response of the system and how it can be measured. Now, using these two inputs, like response and the measure, you need to come up with the tactics which will be basically implemented in a system, so that the desired response is achieved and the desired metric or the measurable outcome can be checked. Now, in order to do that, there are several categories of design decisions that you need to take. We are going to explain that for each quality attributes. So these categories are: one is allocation of responsibilities, second is coordination, third is data model, fourth is resource management, fifth is resource binding, and the last one is technology choice. So when you are taking the design decisions, essentially you need to describe this under these categories. Let's look at these in slightly more detail. So allocation of responsibility, what does it mean? It means that when you are going to implement architectural tactics, in order to address a particular architectural quality requirement given in that particular template. So responsibility allocation means that you have to identify that are necessary for these quality requirements. And second, in other words, why you look at the quality requirement and then identify what are the features that are necessary to implement this quality requirement, and then identify what are the modules, what are the runtime elements that will be responsible for implementing these features. So this is called allocation of responsibility. The second point is called coordination. The coordination is about interaction among different components. You have to describe a mechanism of coordination. Is it a stateless communication? Is it a stateful communication or interaction? Different properties of communication. Is it a lossless communication? Is this concurrent? Which element should and which element should not communicate? Which module should communicate, which module should not communicate? What are the restrictions that you need to describe? In the data model, in order to implement this particular tactic, what are the data structures that you require? How are you going to create those data structures? How do you going to use it? What are the persistence mechanism? What are the destruction mechanism, etc.? How do you organize the data? Example is that, suppose if you are to handle 300 requests per second, you need to, in the data model, you need to describe that what kind of data structure, what kind of mechanism you are going to use, so that these 300 requests per second can be actually accomplished. Resource management is about identifying the resources that need to be managed in order to, while addressing this particular quality requirement. So these resources could be CPU, IO, memory, battery. There are more soft resources like system lock, thread pools, and so on. and have to identify who should manage these things. Many a times this would be managed by possibly the underlying operating system, but in some cases maybe it is the responsibility of the software to manage this, and find an impact of what happens when this threshold is exceeded. So what that means is that when your system is running and you find that the CPU usage goes beyond certain threshold, then what's going to happen to your system? That you need to identify what are the impact and how, and then only you can think of the mitigation strategy. But first you have to identify the impact. What should you do so that it does not exceed the CPU threshold beyond certain point? Who should manage? Is it are you going to implement a monitoring or management tool in addition to your main system, which is going to keep track of this? If your application runs for days and then you find that the memory usage crosses a certain threshold, what should you do? So these are the things that that need to be addressed as of under the resource management. Binding time decisions. This means that you have to take decisions of how you are going to bind different modules. You can use parameterized makefiles. You can use or design a new runtime protocol, a negotiation during the coordination. There could be, in certain scenarios, you could basically come up with a runtime binding of new devices, which is called hot plug and play. So that might be required. Another could be runtime download of plugins or apps from the App Store. So this could be another binding time decision, that how are you going to get the right plugin, and this is definitely architectural decision. Technology choice is about what are the technology that you are going to use. Many a times some part of the technology choice comes from the external environment, the organizational mandate, which is what I was saying is at the beginning, to be a certain design decisions are taken by the organization. That could be even choice of technology, but there are certain technology choices that you can also make. For example, things like what are the commercial of the tool of the shelf tools that you can actually use to implement certain functionality. What are the development environment that you are going to use for the developers? What are the configuration management tools that one can use? So these are various technology choices that the architect needs to take. In addition to these software qualities or system qualities, there are the business qualities, which I said we are not going to cover, but let us look at what those are. Time to market is essentially about competitive pressure. So a very short window of opportunity for the product and system. This impacts functionality because it can essentially tell which functionality to drop, which functionality to keep. Build versus buy decisions are often taken for time to market. Even decomposition of the system essentially, or deploy only a subset of a particular system, that's also impacted by time to market. Cost and benefit analysis is essentially about development effort. Architecture choices do lead to or do impact the development effort. Use of available expertise, technology, etc., that need to be taken, which will also impact cost, and then also one has to weigh the benefit. Highly flexible architecture actually always have higher cost, but you have to think whether it is really required for a particular scenario. Projected lifetime of a system is also another business quality, and now the product that needs to survive for a longer time needs to be modifiable, scalable, and portable. So when such systems live longer, at the time of design itself, the architect need to take these things into account. What are the targeted markets? What are the feature sets for that particular market that one need to analyze in terms of portability as well as functionality? Oftentimes people use a product line approach in this case to address the targeted market. We are not going to address product line in this particular course. Rollout schedules are essentially decided much earlier in consultation with the architect. It's always a phased rollout where there are base plus additional features which are spaced in time, and flexibility and customizability becomes the key parameter. Integration with legacy system is a requirement, and that basically means that you need to address the integration mechanisms well. You need to have a technology choice well, so that integration with legacy systems becomes feasible. Architectural qualities are, there are three architectural quality. One is called conceptual integrity, which means that the architecture should do similar things in similar ways. If there are similar things, you can't just propose different ways to do the same thing. If there is, unless there is a very specific reason. Typically you should do similar things in a similar ways. That's what is expected. Then unified designs at all levels is also very important architectural quality. Correctness and completeness is important architectural quality, so that the architect has to ensure that the system's requirements are met. That's what is called completeness. And runtime constraints are also met. That's also completeness as well as correctness. Buildability is about how the system can be implemented so that it can be built on a timely manner with high quality. It should be open to change or modification as the time progresses. And essentially knowledge about the problem that need to be solved, that we need to really definitely look into. So buildability is an important parameter, that important architectural parameter that the architect need to look into. So in this lecture we have introduced what are the quality attributes, and in specific we have looked at the system quality attributes, though we have also introduced other attributes like your architectural quality as well as business quality. And though they are important and they do impact architecture, they do impact the system, we are not going to cover that as a part of software architecture. We will basically focus on the system qualities, and in the next lecture we will look into each of these qualities in detail. Thank you.